Alright guys, today is a new day and we're gonna solve more AMC 2018 problems, alright? So this is a test A, AMC 10 2018, alright? Now this is question 16, alright? And let's get into it, alright? So it says right triangle ABC has leg lengths AB equals 20, BC equals 21, including AB and BC. How many line segments with integer length can be drawn from vertex B to a point on the hypotenuse AC? Alright, so let's draw out right triangle ABC, alright? So we're going to draw it out. Ugly line. Ugly line. I'm going to keep drawing till the line looks good. Nope. It looks good enough. Beautiful. Beautiful. Beautiful line. Alright. And so we know that there's the vertex right here is B, alright, so B is right here. And then we can label these any A or C as we want, alright? So it says A, B, C. Okay? So we know AB has the length 20. BC has length 21, alright? And we want to find the hypotenuse length, so all we do is 20 squared. Right? A squared plus B squared equals C squared, that's hypotenuse, alright? 20 squared plus 21 squared. What does that equal to? Well, 20 squared is 400, 21 squared is 441, 400 plus 441 is 841. And the square root of 841, well, that is, well, we know 25 squared is what, 625. And if you square something with a 9 at the end, it'll end with a 1. So, and we know 30 squared is 900. So that means it has to be less than 30 squared. So we have 29 squared. Alright, so AC is equal to 29. Okay, now let's get into the problem now, alright? So how many line segments with integer length can be drawn from vertex B to a point on the hypotenuse AC? Alright, so the first thing we have to recognize is that the altitude from B to the hypotenuse of AC, this line right here, the altitude, alright, that's going to be the shortest length possible that you can draw from any point from point B to AC, alright? You have to recognize that, alright? And you know why? Because guess what? If we drew a line up here, that'd be longer than here. If we drew a line going like this, if we drew a line going like that, well, this would be longer than this. Alright, so any line past this little altitude right here is going to be bigger, alright? It's going to be longer in length, okay? So let's try. So now our goal here is to find this B to this altitude right here. Let's call this point that it touches D, alright? And we know that this is a right angle, and this is also a right angle too, because it's an altitude, alright? So this is point D. Okay. Now let's try to solve. Let's call this length right here. Let's call it X, okay? We're going to try to solve for X. Alright. And so the first thing, we want to set up a proportional, alright? We're going to set up two separate triangles. We have triangle ABD labeled here, and we have triangle BDC here, alright? So let's separate them. So we have BDC going on, so we have D, we have B, then we have C. You have this other triangle right here. We have ABD as well, triangle ABD. Alright, now let's label the lengths now. We have AB, which is 20. Yeah, that's the hypotenuse of this. And we have this BD is X. And then we have this one right here, BDC. We have DC. We don't have a value for that. We have BD, which is X also. Same thing as right here. We have BC, which is 21. Alright, what else do we know about this equation? Well, we know angle C in this triangle right here, angle C in this triangle right here, is equal to angle C in triangle ABC. So let's label that, alright? So they're equal. And we also know that angle A and ADB is equal to angle A and ABC also. So let's label that as well. And so from here, and we know that these right triangles, these are all right triangles, so we can prove their similarity by angle, angle, angle similarity theorem, right? They all have the same angle because 90 plus this similar angle plus this one would have equal, would be equivalent to each other, okay? So let's set up a proportion now, all right? Now that we have similarities. Well, we want to solve for x, all right? So we have 20. So 20 is the hypotenuse of ABD. 29 is the hypotenuse of ABC. All right, so let's set it up. 29 over x, right? We want to solve for x is equal to 20, or not over x, I'm sorry. 29 over, well, we want to find the corresponding point to x, or corresponding line to x, right? So if we had 20 over x, right? X is going to be this bottom one right here. And same thing here, we're going to match this bottom one right here, so 21. And do you see why? 29 is the hypotenuse, and 21 is the bottom line for this one. And it corresponds to ADB. 20 is the hypotenuse, and X is the bottom one. And all we do now is multiply, all right? So we have 20, we're going to cross multiply. We have 20 times 21, which is 420. And then we have 29 times x, which is 29x. And then we divide 420 by 29. So we're going to do that at the bottom right here if we have space. Divide 29 on both sides. So 29 goes into 42 one time. So 29. 42 minus 29, what is that? Well, that's 12, that's 13, all right? Or 14, I'm sorry. 14, then you have the 0 right here. 29 can only fit into 140 4 times, all right? What is 29 times 40? I'm trying to do that in my head. That is 116. 116. That's a very ugly 116, but you get the point, all right? So 140 minus 116 is going to be 24. And look, and you're gonna have, and we're not gonna go all the way out, right? So we just realize we're gonna have some decimals right here, right? But we know that this length is going to be greater than 14, all right, because we're going to have all these decimals. And so we can't have it's telling us integer length, so we can't have a decimal here, all right? So our integer lengths have to be greater than 14, as in 15, 16, 17, so on, all right? So let's look at what our integer lengths can be. They can be 15, right? They can be 15. They can be 16, all right? Let's count 15. It could be 16, it could be 17, it could be 18, 19, 20, and we stop here at 21, right? Because 21 is this length right here, BC. And BC is going from point B, the vertex, to C, which is part of the hypotenuse. And that is this length right here. And we can't go 22, right? Because that'll go past this point right here. It'll be longer. So all we have is these points right here, 15, 16, 17, 18, 19, 20, 21. And how many points is that? That's 1, 2, 3, 4, 5, 6, 7. And then we have to multiply. We have to multiply this little chunk by times 2, right? Because all we did so far was include these points. We didn't include the ones up here yet, all right? And the ones up here doesn't include 21 because 20 is the greatest number you can go. So we multiply these ones by 2, so that's 6 times 2 is 12. 12 plus 21, or just 1 point right there, so 12 plus 1 is 13. And we have our answer 13 right here. And there you go. That is how you do it.